So we're going to be talking about some supply chain shenanigans today. And why supply chain shenanigans? Well, because it's been a very hot topic in the past couple of years. And even though a lot of supply chain attacks happened, a lot of companies got hurt and lost millions and billions of dollars, developers are still doing it. And they are still they still don't care about packages that they use in their applications. Okay, wait just for a little bit for more people to get in. In the meantime, are there developers in the audience? How many developers here by a raise of hands? A couple of them? Okay, maybe half. But I suppose that most developers will be here because QAs will be at the Selenium guys talk, not here, so yeah. So since QA are not here, we can bash on them, right? QAs are the worst. All right. So, yeah, I'm not going to get too much more of your time. Let's talk about who I am and why I'm here. My name is Todor, and I'm a senior software engineer at Payhawk. I'm a chapter lead for the OWASP Sofia chapter. I don't know if you know what OWASP is, but it's a great nonprofit organization for application security. We do meetups every month, talk about application security topics, and it's really interesting. I've been a speaker for the last couple of years. I'm a community supporter. There is a really cool Discord community server for security-minded people. It's HackerBG. You can go check it out. It's really nice. And I'm an open source contributor. I love everything open source. I love packages. So let's talk about packages. I'm sure you've seen those logos, and maybe you know what they are about and why they're here. But some interesting trend that's been happening in the past couple of years is regarding supply chain attacks. And you can see that it's exponentially growing, and that's a huge concern. And that is causing a lot of problems in the industry lately. A lot of very serious security breaches have been happening, supply chain attacks, hundreds of applications and websites. There was a very cool malicious attack of NuGet packages using an MS-built loophole a couple of years back. The Python package hell that kind of stopped all of the packages in the Python package repositories for a couple of hours because of fighting off supply chain attack attempts. And you might be wondering, but why this is happening? I'm going to tell you why this is happening. And tell me how many times you've seen something like that. And most importantly, if you're a developer, you've seen it every day maybe. Most importantly, that part here. So you have to know that packages are evil. And they can be very evil, and they can do a lot of harm to your software. And just to demonstrate what can be done and achieved immensely easily, I'm going to do a very quick demo. And in that demo, I'm going to show you a package that I've created, which is called Awesome Validations. So because, developers need to validate a lot of data, so they very regularly want to use cool packages that they can validate data more easily. And I should know that because I have an actual open source package, which I'm a contributor of, I'm the creator of. But we're not going to talk about that. We're going to talk about my malicious one. It's called Awesome Validations. Don't look for it on NPM. It's not really there. I just set up that for the presentation. I don't want to put it there because I don't want my user to be banned. And that would happen if I put that on NPM. So what is that package doing? Let me show you a very quick demo. Okay. So, do you see in the back? Everybody see the text? So, I've created a very simple NPM package. It doesn't have any actual code in it. and I have a very simple legit application that will be using that package. So here in my terminal, I have both of those. So I have the Docker file, which I'm running currently because it's running in a just Alpine Linux container. So I have the legit app, and I have the shady package app. So let's go to the legit app. And I have nothing there. I have just a package JSON, which you can see here is just a very empty package for a legit application that's doing some stuff. And I'm going to install my shady package inside that. And I'm going to install it from the file, not from the repository, because I said I didn't publish it there. But as the same way you will run npm install. Before that, let me show you something. So here I am in my home directory, and there's nothing here. So if I go back to app legit package, and I install my malicious one, it will tell me everything's great. It's just notifying me that my npm is an older version. That's a normal one. But if it doesn't have any vulnerabilities. It's installed, and now I can start doing some validation. But if I go back to my home directory, I have a little file there called hacked. And if I see what's inside that file, it is my pass.dw file, which meant that package, which I just installed from somewhere, has a very easy access to my users and passwords and can do whatever it wants with them. So for the sake of presentation, it just puts them in this file, but it can do everything else. And the code for that package is on GitHub. You can go check it out after that. Everything's there. You can see how, with a simple post-installation script, I hacked you by just installing the package. You wouldn't know that this happened. And that happens on a daily basis everywhere. And here I'm going to talk about how those things are happening and how we can prevent that from happening. So there are a couple of very popular supply chain attacks that can be achieved with different packages. And the first one is called a substitution attack, an npm substitution attack, or a dependency confusion attack. So how that works? Usually, you have a public package repository that has all of the packages that you will be working for, right? Either it's npm, either it's NuGet, it doesn't matter. Most companies have a private package repository where they store their own packages, and they usually proxy off from the public one to their private one so that they can have, for compliance reasons, they can have a copy of those packages in their private repository, and they scan it and things like that. Okay. And we have some developer, a client machine, which has some console utils package, which is an internal package to my fictitious company here. And you can notice here that it's been added with wildcard versioning, which means essentially that I want to be able to install whichever version of that package, minor version of that package there is, so I don't have to go and do it manually. And that's, by the way, the default way of adding packages to your packages JSON file when you just run npm install. And when I want to install a package, it goes and checks into the private repository, which has that version, and give it to me. But if it doesn't have that version, it also checks to the public repository. And there, a malicious actor could have published a package with the same name and a bigger version than my last one. And that package can have malicious code, like the one I just showed you. And when I want to install it, boo, that package will come to me and infect my computer. And that's how npm substitution attacks happen. They're not very common, and they're not the most frightening ones, but they are there and they can happen. How can we prevent that? First, use strict versioning. Don't use wildcards. I know it's very easy. I know people like to use them because they don't want to think about dependencies, but please don't. Know your packages. Use scope packages, which means that if I have my own packages, I will be using a reserved scope for them so that nobody with that add scope, all of the big package providers support something like that, will be able to push a package with that name. This way, they won't be able to push a package that I use. Do not leave vulnerability warnings unattended. So the one that I showed in the beginning, do not leave warnings, even medium ones, because if you leave medium ones, then you'll start leaving high ones, maybe some critical ones, maybe it's just a fake one, blah, blah, blah. That happens all the time. We know it. You know it. Validate checksums. You can go and check if the package that you're getting is the same one that is supposed to be given by the provider or by you. All of the big packages, all the packages provide such checksums. You should do it for your own packages as well. Include a package log file. Many times developers don't want to commit their package log files so that they can have less merge conflicts. But this is exactly what is preventing you from automatically installing minor versions from transitive dependencies. And use auditing tools during your implementation. There is a really good one called MPQ, which is for NPM packages, which tries to do additional due diligence of your packages upon installing. All of the things that I'm talking about have links inside the presentation. You will get that after the session is over. It will be on my website, and I suppose the organizer will give it to you as well. So MPQ is a really good one for that. So on to the next attack. The next attack is called typo squatting. And that is a very prominent attack that's been happening quite often lately. And it seems like a no-brainer, but it's really easy to achieve. There was a typo squatting attack that happened last year that delivered a lot of rootkits via NPM. And how that works. So I'm going to give you this example here. There is a very popular package called Node Hide Console Window, which is used in a lot of websites. So there was a package published to NPM, this one. Did you notice the difference between those two packages? Let me show that closely. So when you're installing packages, and how often do you just write Windows and not window and just hit enter, and boom, you have the infected package on your system? It's that easy. This is the legit one. This is the malicious one. And that was an actual malicious package published to NPM. It's not available anymore because NPM marked it, but still, it's there. Also, it's not currently happening because it's not a problem anymore, but in the past times, package names were case sensitive. So those two packages were different ones. Again, the lower one was a malicious one. The upper one was the actual one. People were installing the later one. Again, there is a cross-env package, which a lot of NPM services are using for handling environment variables. There was a big typo squatting attack recently that they've discovered a lot of packages which mimic actual packages inside NPM. And all of those are actually malicious. None of those are written in the same way by the actual packages. And on the right side is how many times they were downloaded. So crossenv was downloaded like almost 700 times. 700 PCs are being infected by this one. And this is actually how the actual one is called. It's cross-env. And this was the malicious one. Same thing happened, a typo squatting campaign in Python couple of months ago. Here are all of the variations of actual packages that people are using. TensorFlow, Selenium. They're talking about Selenium in the next hole. So all of that you can easily get and infect yourself. How can we prevent something like that? Well, package managers need to do more. They are already on top of their game. They're trying to achieve, to mark those packages and identify them and stop them. This is what you would see for a package which was identified by NPM and not available anymore. But they can do even more. Something that's immensely easy. Don't write the name of the package. Check it out in NPM and just copy-paste it. Is that it? So you don't write Windows. And that works for all of the websites for different package managers, NPM, NuGet, Python, they all have something like that. So just copy the command and paste it in your terminal. Don't try to write it yourself. Again, don't leave vulnerabilities in your code. And a very, very important one. When you're installing packages, that works again for NPM, works for NuGet. There is always a parameter for ignoring post and pre-installation scripts. The attack that I showed you in the beginning was achieved through a post-installation script. If I had installed it with that, I wouldn't be hacked. And you can even put that in your NPM config and have it by default for all NPM installs. So please go and do it today. And last but not least, educate your developers. Educate them on stuff like that. Bring them to sessions like that and tell them what can happen when they want to install whatever they want and whatever they want. And the third type of attack that I'm going to talk about is actually the most harmful one and the most dangerous one, which I'm calling an open source dependency injection attack. This one is very prevalent and it happens a lot lately. And there was a really cool article in Medium a couple of years back, but it's still very, very on top of its game. It's called How I'm Harvesting Credit Card Numbers and Passwords from Your Website. And I urge you to go read it. You will get the link inside the slides, but I will go through what the guy is talking about in that article very quickly. So step one, create a seemingly harmless package like the one I showed you in the beginning, some validations package. He was talking about the package that he created for printing pretty colors in the console while developing. Create something that and put a malicious code inside of it. Step two, open a lot of pull requests in front-end packages around GitHub. Popular ones that everybody are using. With, hey, I fixed that issue for you, and I also added some cool logging to the console. Most of those won't work, but there will be few that will accept your pull request. And profit. That's it. You don't have to do anything else to achieve that attack. And I'm not going to even mention the XZ attack. I'm sure all of you heard about it. It was an amazing and hard to achieve nation-state attack on a very core package that is part of all Linux kernels. And it was, if they managed to put that into production, that would reach all Linux servers all around the world. Frightening stuff. And that was exactly that type of package. They managed to put malicious code inside a very legit package by a very long campaign of fooling the maintainers of that package. So, how do we prevent that? Well, that's the tricky question. What the author of the article that I mentioned suggests is just go live in the woods. Because that's the only 100% sure remedy for such attacks. Just go live in the woods, no internet, no computers. This is how you prevent it. And if you don't have any packages, you don't have to worry about it. But yeah, let's be serious for a moment. So, how do we prevent it? Do not use packages on sensitive parts of your system. If possible, and I know that's very hard to achieve because we don't want to reinvent the wheel all the time, but on authentication parts of your system, on parts that are handling credit card data, on parts that are handling access to your database, all of that, minimum packages used. That's a really one of the best advices that I can give you. Keep your dependencies up to date. I also know that this is hard. I know that things break. I know that you don't have the time. You have to work on that new cool feature that product wants, and you don't have the time to update all the package dependencies. But leaving a old package with old vulnerabilities will bite you. And last but not least, know and limit all of the things that are going outside of your network, outside of it. That's a no-brainer. But usually when you get hacked, they want to extract something out of you. So don't allow them to connect to their command and control centers. Just stop all that traffic. Also, there is a really cool project by Google. It's called DevOps, where you can do additional due diligence of packages. It works, again, with all of npm, Go, Maven, NuGet, whatever. You just put a package there, and it will tell you where it's coming from, how legit the authors are, what other different links to that package, what might look suspicious, things like that. It's a very cool one. But I'm sure that there will be people in the audience that will say, well, I don't use external packages. I write everything myself. Nobody's going to hack me. Nobody's going to do a supply chain attack. Cute. So, open source projects have an average of 180 package dependencies. That's just an average. So, how many of you use Visual Studio Code? Yeah, and the others also use it. They just are very shy to raise their hand. So everybody uses Visual Studio Code, right? And as you know, or maybe you don't, but you should, Visual Studio Code was built with Electron. And Electron is a really cool thing, but it's essentially an NPM package. And that NPM package, it doesn't have a lot of dependencies, just 3 of those. But those 3 dependencies bring that dependency tree. So this is the package dependencies that Electron works with. I know it's not that much, but behind all of those packages, those are the supporters. Those are the people that are writing code inside those packages. So all of those 98 maintainers, their code is in Electron and essentially in Visual Studio Code. And I don't know about you, but I don't trust I am evil rabbit. And we don't trust people on the internet at all, right? Because they are evil. And this is what happens. You don't use external dependencies, but Visual Studio Code has Electron. And even if you don't use Visual Studio Code, because you're not a developer, well, Electron is used by Microsoft Teams, 1Password, Slack, you name it. So everybody in your company is using Electron in one shape or another. So I Am Evil Rabbit's code is in your laptop, in your server, whatever. And I know that all of that sounds very doomsday kind of feel, but take a chill pill. It's not all lost, and there are, again, ways. And what are those ways? Know your dependencies. Don't just put dependencies for the sake of productivity. Don't just put whatever you need just to not write additional 10 lines of code. Use less when possible. As I said, especially on sensitive parts of your application, do not use dependencies. Write the code yourself. Utilize tooling for scanning, insights, monitoring. There's tons of open source free tools that you can utilize. You just have to find a way to include them in your pipelines, to include them in your processes, and you can benefit a lot from out of that. And last but not least, educate your developers. I cannot stress this enough, because I usually, when I do this talk, I always want to stress on that part, because all of the other things, everybody are trying to do automation, everybody are trying to do scanning, but at the end of the day, the developer is the one that needs to know what can happen and how they can try to prevent it. And they need to share the pain, or as I call it, pain-driven development. So they have to share that pain. And you will ask, well, okay, but why? Do I have to care about this only about security? Of course, no. Because there is a legislation by the European Union called the EU Cyber Resilience Act, which is not yet in effect, but it's going to come in effect in a couple of years. And that Resilience Act will make you have a bill of dependencies, a list of bill of dependencies, audit logs for all of your dependencies, where they're coming from, what do they include, blah, blah. So all of that thing, all of that due diligence that I'm talking about, you will be forced to do it in a couple of years. The same as with GDPR, this is what it means for dependencies and for security. So what I want to always say and really, again, bring you that thought, create a culture of thoughtful dependency management rather than using packages solely for productivity. So know and have a good reasoning why you're adding that dependency there, why you're adding that package, and what could be the consequences apart from it. With that, where you can find me, by the way, this is me on John Travolta's hat. You can find me here. I promise it's not a malicious QR code. You can scan it, or you can find me there. Or if you don't want to scan it, just look for my tag on all of the social platforms. It's the same in GitHub, whatever. You can reach me if you want to have a word, if you want to have some questions. I will be here all day. Get to know me, and thank you for being here.
Thank you. We have some time. Maybe we can do a round of questions. Don't be shy, folks. There you go.
Hey, thanks for the talk. You told us to keep the packages up to date, but that's in itself the attack vector, right? Like if I update my packages, that's how new, malicious code gets in. So
yeah,
I'm not going to update my packages. What should I do?
Yes, that's how new malicious code gets in, but that's how old malicious code gets out. Because usually there's a lot of malicious code in the packages or vulnerabilities in the packages that you don't know about and people don't know about. And again, when you're doing an npm install, when you just see it in the output, well, I get why developers don't want to update their packages, and they don't care about the output of npm install, like there's vulnerabilities, because a lot of those are false positives. And I do know that. I'm a developer. I have done that many times. But that's why I'm talking about creating a culture. We need to create a culture where developers are not dismissing that warning so easily. I want them to be afraid. I want them to, when they see that warning, there's something inside of them that makes them, I got to check that out. Maybe it's nothing, but maybe it is. So this is what I want to give you as a food of thought.
Thanks. Any more questions, guys? Okay.
Okay.
Then we're ready.
Yeah.
Yeah, a round for applause.
Okay, thank you. Thank you very much.
You can